Hello classmates, my name is Lizzie Marie Torres and the problem that I got chose to do was Unit 4, Section 4.1, Number 1, Representations and Word Problems. The first model that I'm going to be presenting from this problem is the discrete set model. It's important to note that discrete modeling means it typically involves a discrete set of values or objects. So, it is possible to use the discrete set model and linear measurement models to understand multiplication. There are also area models and Cartesian product models in multiplication. So for the discrete set model, our problem is 5 times 3 in the context or the variety of cost of each fish times the number of fish, and that's going to give us our total cost for fish. The example that I wanted to give would be one fish costs 5 cents. How many does 3 fish cost? And to figure this out, maybe we would have our students draw a picture of 3 fish, and we would know each fish cost 5 cents, and we would add each one of those up together for a total of 15 cents for 3 fish. And that's the discrete set model for the problem 5 times 3. The next model that I'm going to be presenting is the measurement model for the problem 5 times 3. The measurement model is going to be in the context of number of fish tanks times the number of fish in each tank equals the total number of fish. It's important to remember that the measurement model of multiplication is the number of groups times the number of things in each group. So the example that I give is that the aquarium has 3 tanks. Each fish tank has 5 fish. How many fish total? So we could draw our separate fish tanks, which will be 3. We have 3 tanks. 2, 3, and we would draw our 5 fish inside each tank. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So then we would just have our students add each one of the tanks together. 5 plus 5 plus 5 for a total of 15 fish inside each of the 3 fish tanks. And this is the measurement model for the problem 5 times 3. The next model that I'm going to be presenting is the area model for the problem 5 times 3. An area model is a rectangular diagram or model used for multiplication, in which the factor is used to define the length and width of the rectangle. So, I'm going to be doing the problem 5 times 3 in the context of length times a fishing net times the width of the fishing net. And that's going to give us our total area of the fishing net. So, I would tell my students, for example, I have a large fishing net that measures 5 by 3 feet. What is the total area of the fishing net? So, I would have my students draw a picture of the fishing net. Doesn't have to be perfect. And it would be 5 by 3, the length times the width. So we would do 5 times 3, 5, 10, 15, for a total of 15 feet. The fishing net is 15 feet. And that is the area model for the problem 5 times 3. The last model I will be sharing is the Cartesian model for the problem, again, 5 times 3. The Cartesian model in mathematics specifically is a set theory, the Cartesian product of two sets, A and B. In this context, we're going to be presenting the Cartesian model in the number of types of fish times the number of kinds of fish, and that'll give us our total number of fish. The example that I would give my students is there are 5 different types of fish. If there are 3 kinds of each, how many fish are there all together? This is the Cartesian model chart that I would present to my students, and there would be 5 different kinds of fish, and stemming from the 5 different kinds would be 3 different types. And then we could count up the different types to see how many fish there are altogether. If there are 5 different types of fish and there are 3 different kinds of each. So from guppies, we would have tiger guppies, red guppies, and albino guppies. From our goldfish, we would have silver goldfish, pond goldfish, and longtail. From our betas, we would have male betas, females, and baby betas. Our tetras, we would have neon tetra, glow, and white. For our tropical fish, we would have clownfish, jellyfish, and starfish. Let me see how I can fit it on there. then to know how many fish there are altogether, we could count up our different types, giving us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 fish total when we do our problem with the Cartesian model for 5 times 3.